This is variable. This is also for audio frequency. Frequency band limits. Frequency, next one is frequency band limits. Here we have total 10 frequency band limits. Next one, requirements of laboratory type signal generators, that is variable signal generator. These are the things. These are the different points required for a laboratory type signal generator. From here, we are starting the diagrams. Standard signal generator, explanation for that. Advantages, disadvantages, applications. It's a sine wave generator, square wave generator, sine and square generator in a single device. This is a simple converter for converting sinusoidal signal into square wave. Front panel controls. And their description. Next one is a function generator. In last class we have completed this particular. It's a normal function generator. Next one, square and pulse generator. Square and pulse generator. This is a simple pulse generator. And this is the somewhat detailed block diagram for square and pulse generation. So this is square and these two are pulse. Please wait. This is pulse. Please wait, ma. Here my system is stuck. So this is square waveform and is nothing but pulse. Sorry for the delay. It's a pulse. Here 600 ohms and here this is 50 ohm. According to the requirement, we can select these two types of 50 ohm and 60 ohm. These two are for compatibility of the output. compatibility of the output. For each and every device, we are taking the compatibility issues. So this is output and this is input. This is our FG, for example. So this is CRO. We need to connect these two by means of its impedances. So these are the impedances. So this is the diagram we have explained previously last class. So next one from this for this class, requirements of pulse generator. Requirements of pulse generator. That means what are the different required for it's to generating a pulse signal using a generator. So pulse should be have minimum distortionless. Please note down parallelly. Pulse should have minimum distortionless. Very minimum distortion. Basic characteristics of pulse are rise time, overshoot, ringing, sag, and undershoot. So these are the basic requirements of the pulse waveform. See here, rise time, you know that, overshoot, ringing, sag, and undershoot. These are the basic requirements of the pulse signal. Pulse should have a sufficient maximum amplitude if appreciable output power is required by the test circuit. Sufficient maximum amplitude. That is also the main requirement. Attenuation range must be adequate to produce small amplitude pulses to prevent overdriving of some test circuits. That means we have to maintain the attenuation also to minimize the attenuation signals using this attenuators. DC coupling. So previously we have taken a 50 ohm coupling, 600 ohms coupling. Like that, here we have DC coupling also. The range of frequency control of pulse repetitive rate should meet the needs of the experiment. So pulse repetitive means, for example, this is one pulse, this is another pulse. So in pulse we have a condition for there is no not necessary for generating the same pulses in a train. For example, this is 50 milli and this is 20 milli and this is again 60 milli and this is 10 milli, this is 5 milli, this is 20 milli, like that. Each and every pulse having their own. Each and every pulse having their own characteristics. That's why if it is completely repetitive, then that is it's a good range for the experimentation. Pulse generators can be used to produce trigger signals when this output is passed through a differentiator circuit. That means which is used to eliminate the distortions in the circuit. The output impedance of pulse generator should be matched to the cable and the cable to the test circuit. So that means this pulse generator is applying to the circuit. That circuit is must and shouldly matched to the next level of the circuit. So if it is the mismatching is done, then you have to compensate, otherwise you loses the data. So that is nothing but that point. The output impedance of pulse generator should be matched to the cable and the cable to the test circuit. Mismatch causes energy to be reflected back to the generator by the test circuit, which may reflected by the generator causing the distortion of the pulses. Automatically the mismatching causes the distortion. So these are the requirements, and this is the diagram for the pulse waveform. And of course this pulse waveform consists of, see here, it's a overshoot, ringing, this is positive pulse, overshoot, ringing, positive pulse, negative pulse, overshoot, undershoot, sag, all those things are available here. Rise time, all those things are available here. So this is overshoot, ringing, this is droop, this is fall time, rise time, this is positive pulse, this is positive, and the below one is negative, and this is negative. This is positive, the below one is negative. And this is negative. Below this is negative. This one is negative. This is positive. So please note down that waveform. Make it fast. Please note down the diagram. Please note down that waveform. This is a simple waveform and which consists all those things of overshoot, ringing, droop, pulse, rise time, fall time, positive pulse, negative pulse. And these are the percentages of amplitude: 10%, 50%, 90%, and 100%. Completed? Completed?
Yes, sir.
So next one is random noise generator. Just put that heading of random noise generator. Random noise generator. Any one of you, what is nothing but noise? What is nothing but noise? Noise means what? When we call a signal as noise, noise is nothing but, please note down, unwanted form of energy. Noise is nothing but unwanted form of energy. Energy is nothing but which consists of information. If information is nothing but which is defined one. Information is nothing but defined one. For example, in a classroom, a faculty is only the speaker. In a classroom, a faculty is only the speaker. So that is nothing but information, and that is wanted for that class. In the other hand, in the same classroom, number of students are murmuring. At that condition, for that class, that particular murmuring of the students is unwanted to the class. That's why that is nothing but unwanted form of energy. So of course, that particular one is wanted for the student, but which is unwanted for the class. So that's why if you have any doubt also, you can resolve that doubt after the class, or you can just inquire that doubt with the faculty only. So you don't mingle with the other students for the inquiring all those things. Of course, that is nothing but we call that as noise. So noise is nothing but unwanted form of energy. Other hand, we have another type, that is distortion. So anyone, what is nothing but this distortion? Distortion. What
Unwanted
is
signals.
what?
Unwanted
Distortion.
signals, sir.
Yeah, that is nothing but that distortion is nothing but this distortion is undefined one, and this is not information. That is not information, and that is not meaningful, and that is not meaningful. Here, this is nothing but the difference between noise and distortion. Noise is nothing but a signal, but which is unwanted. For example, in a television, if you want to watch a particular program of X, at that time, Y program is also displayed as background of that X program. Then that X is your wanted information and Y is unwanted information. So just you want to see X program only, but in that X program, in its background, that Y program is also displayed. So that Y program is nothing but unwanted form of energy. Here just you wanted to see only the X program only. What about the Y program? That is noise. So here the distortion is nothing but those two programs are mixed to each other, and it gives the accomplished distortion, and you are not able to see any program. You are unable to see any program. So that is nothing but a distortion. That means if you are watching something, that is nothing but noise. If you are not watching anything, it's completely unable to see at that condition. That means there is no information at that condition. That is nothing but a distortion. Same in a audio signals also. So number of persons are talking in a market, that is completely a noise, but not a distortion. It's a noise. Nothing but if you are able to tune a particular person, it is wanted information. So all those persons are talking at a time, that is nothing but we call that as noise, but not as a distortion. If that noise, if the talking in the all the persons in a market is just look like as unwanted form, that unwanted form is nothing but you are not defining that, and which is not meaningful. So that condition is aravadam. That is also nothing but they have some fear. So like that is also the information. But they are quarreling or like that, which is not definable. So that is nothing but so distortion. Here, this word so noise is nothing but that particular. And here that random is nothing but not so continuous. Not so continuous. That means by mixed you can fix a single. By mixed you can fix a single. So that is nothing but random. Here you have one doubt, that is sir, so noise is nothing but unwanted form of energy, but why we are here generating the noise? Actually there is no need of generating. So noise is nothing but unwanted form of energy. So that why we are generating, what is the need for generating that unwanted form of energy? So that is the basic question, that is for to test the signals. So this is a noise limiter. For example, a circuit of noise limiter. Here I am applying input, and of course it need to produce output without error. That means we need to verify that. In second condition, in addition to that input, here I am applying noise. So noise is nothing but we have some specific noise. So that specific noise is nothing but here we are applying that noise signal of, for example, a white noise. Here I am applying a white noise. So noise is applied. So now here this noise limiter is able to reject that noise or not. So that just for testing. So what is the need for generating the noise? Because of to test the signals. To test the signal. For example, ఏదైనా ఒక ప్రాబ్లం మనకి ఉంది అంటే if you want to if you are giving a particular medicine to that problem, first of all you have to generate that. You have to generate that. Without that problem, that means you don't know about that problem. So what is the procedure, or what is the remedy, or what is the cause for to generating that particular? For example, nowadays we are using Covaxin or Covishield for the vaccine for this COVID-19. So without knowing the characteristics of the COVID-19, how can we generate that particular Covaxin or Covishield? So that's the thing. That means if you know about that particular completely, then only we are ready to eliminate that particular, same as that. So a signal is suffers with these types of random noises. So first of all you have to test that circuits with that circuit is able to eliminate that particular or not. So for that purpose, initially I am generating the random noises by using random noise generator. So this is the main motto of taking that noise generator into the consideration. See here, it's a block diagram of noise source. It's a block diagram of block of noise source. Here we are generating 80 to 220 kilohertz, but basically we need only 100 kilohertz only. Only 100 kilohertz. That means it's a 100 kilohertz modulator. Of course, this noise source acts as M of t, and this oscillator acts as C of t. This modulator produces it as S of t. This is nothing but message signal. This is nothing but carrier signal. This is nothing but modulator, and it produces the modulated. So based on this modulator, we can fix the different noises as filters. That means if you are use it, that means here we have some functional switch. Here 3 types of noises we have based on the characteristics. By next slide we are seeing that what is white noise, what is pink noise, and what is Usasi noise. So based on that filter, here we are taking that output to the amplifier. That means this is functional switch. If it is connected to white noise, here that white noise is availed here. White noise. In second condition, we are connected it to the pink noise. The pink noise is availed output as the output here. We connected this functional switch to Usasi noise. The output of Usasi noise connected to this output here. So simple by using this functional switch. So at any time, just we are connected it to the only one. Connected it to only one. So this is normal functional switch. So this is filter. You have to get that by using that filter. Internally there is some functional switch, and this is amplifier. Here and here we are using amplifier to get adequate voltage levels, and this is the output of that particular noise. This white noise, pink noise, Usasi noise, these are the different types of noises. You may take different noises also. Please note down this diagram, make it fast. Completed.
Yes, sir.
Please note down these points also. Used for testing of various systems. What is the main purpose of this random noise generator? This is for testing. Note down the points parallelly. It offers the possibility of using a single measurement to indicate performance over a wide frequency band instead of many measurements at one frequency at a time using that functional switch. The spectrum of random noise covers all frequencies and is referred to as white noise. So this is nothing but white noise. That white noise is nothing but having equal power density at all frequencies. That means that signal look like as voltages are same but frequencies are different. Voltages are same but frequencies are different. Here the frequency and here the frequency and see here the frequency. These in these three cycles we have three different frequencies. Such type of signal is nothing but white noise signal. The spectrum of random noise covers all frequencies. The lower density spectrum tells us how the energy of the signal is distributed in frequency, but it does not specify the signal uniquely, nor does it tell us very much about how the amplitude of the signals varies with time. Of course, that is nothing but based on the white noise and frequencies, their amplitudes both are equally correlated. Next point, the spectrum does not specify the signal uniquely because it contains no phase information. So that means only here we are specifying voltage and frequency of the signals only. The frequencies are completely 0 degrees and there is no variation in the phases of the noise. There is no frequencies. See here in this previous, here we have all the frequencies with 0 or 360 degrees only. That means here we are not mentioning any phase variations of the signal. For all those, that frequency phases are no phase information. That means there is no phase variations. The method of generating noise is usually to use a semiconductor noise which delivers frequencies in a band roughly extending from 0 to 200 kilohertz. The output from the noise diode is amplified and heterodyned down to audio frequency band by means of balanced symmetrical modulator. That means here, of course, it generates that 80 to 200 kilohertz, but we need to transform it into 100 kilohertz only by means of internally connected symmetrical balanced modulator. Symmetrical balanced modulator. So this is that symmetrical balanced modulator. So this is. What is the another name for a balanced modulator? It's a balanced modulator or product modulator. Other name is balanced modulator, product modulator for balanced modulator. So pink noise is also called because the lower frequencies have larger amplitude similar to red noise, red light. Pink noise has a voltage spectrum which is inversely proportional to the square root of frequency and is used in band analysis. Please note on this point. The last one is Usagi noise. Is arranging simulates the energy distribution of speech and music frequencies and is used for testing audio amplifiers and loudspeakers. Nothing but Usagi noise is only used for the music frequencies, not for audio, music frequencies. That means recording purpose. So audio amplifiers and loudspeakers. Completed. And this is noise spectrum. See here, the frequencies and voltages are completely variable. See here the edges, of course the pink noise, here somewhat slope and here also somewhat slope. Usagi noise, here somewhat slope, that means deviation. Here also a deviation, here also a deviation. In white noise, here a deviation and see here a deviation. That means which are not so continuous. Note down that. These waveforms are not so exactly like that, but we are representing it as like this. If you want to modify, but no problem. But these are not so continuous. That is only the theme. Completed? Completed?
Yes,
Yes,
sir.
sir.
Okay. Let's note down applications of random noise generator. Please note down these also. Applications of random noise generator. Next one, arbitrary waveform generator. Here, first of all, just go through that. Arbitrary waveform is nothing but arbitrary waveform. Nothing but generally by using these signal generators or function generators, these two are used to generate sine wave, square wave, triangular wave, rectangular wave, step, pulse, exponential, all these things only. Please see it one more time. These signal generator or function generators are used to generate sine wave, square wave, triangular, rectangular, step, pulse, exponential. But these generators are used to unable to generate data of digital signals. With storage. Here a question is there any memory elements used in this signal or function generators? They say yes or no. Memory elements
No, sir.
are say yes or no.
No, sir.
No. That means in these signal generators there is no memory elements are used. Why? Because all these signals are termed as analog. And of course, we call these signal generators as analog signal generators. Here there is no memory. Internally there is no memory. So in other hand, a particular generator which is used to generate a digital signal instead of analog. So digital means it's a process of internally the process starts from processor. Internal that process starts from processor or microcomputer. But this analog signal is nothing but simple generators we are using, like semiconductor devices we are using, not we are using any processors. So that means basically we are using the processor or like that. Later for the convenience you may convert that into analog signal for the further applications, whatever it may be that. But means so digital signal initially available. That means I want to communicate with a system, or you want to take from that system. Of course, that system always generates digital data, always that generate digital data. For example, here I am talking in front of my laptop. That laptop initially takes my analog signal. Later, it converts that into digital. Later it's conditioning that, processes that, and transmits that in the form of digital. And in your home, your device of laptop or mobile or any other normal desktop system receives that information, and which again that transforms the data and convert the digital data into analog for your convenience, and you are able to hear that analog data very easily. But here I am giving analog data, there you are receiving analog data. So in between the two systems taking that analog data, and that means my system takes that analog data and convert that into digital and then processing and that sends transmitting the data, and your system takes that digital data and processes the digital data and converts the digital data into the analog. So this is so like that. Here we are using a generator. That generator is used to produce only the digital information. So digital information only. But in our analog electronic circuits, that means in our normal circuits, there is no circuit is operated with digital information. There is no circuit operated with digital information. So that's why in further condition, you need to convert the digital information into analog. You need to convert the digital information into analog. So by using that a simple converters. After conversion, so that digital information, which is nothing but exactly that analog information, that is exactly equals to the digital, but the characteristics are different. So after conversion, that signal acts as normal analog information. But here we are processing digital information in the form of analog. We are processing digital information in the form of analog. So that is, such type of generators are nothing but arbitrary waveform generators. Such type of generators are nothing but arbitrary waveform generators. So simply we call that as those as AWG, arbitrary waveform generator, AWG, with a short name of AWG. See here we have a simple block diagram here. It's a clock oscillator. Clock signal is nothing but, this is nothing but clock signal. This is for the operation, and this is address counter. And here we are specifying the address. Using the manipulated data here. And this is waveform memory. That means here that particular this waveform memory is nothing but here it has some different locations. So this address is specified here. Then of course this is the particular location. So this data sends to this particular location only. So data is stored here in this memory. So this is data. Later we are sent it to the digital to analog converter. Actually up to here this AWG process is over. This particular block is nothing but AWG converter. That particular block is nothing but AWG converter. So later this is for our analog conversion. So digital to analog converter. So here the information is analog. And this is a filter for selecting specific. And this is amplifier attenuator. This is for normal sake, for fixing the voltages. These two are for fixing the voltage. Fixing the voltage. So here, simple here. Here we are discussed about the need for the AWG, and here how to generate simple by using one clock. Here specifying the address, and here the address, according to the address, so waveform is stored in a particular memory. Then this is nothing but data. Of course, with this block diagram, it states that our AWG. Later, this is the processing of digital to analog converter. Digital to analog converter. Here the digital data converted into analog, and furtherly we are given to the low pass filter for selecting the such frequencies, and here these two are for selecting the frequency, and here this is nothing but output. This output is nothing but analog output, and here this analog output is exactly matches to the digital information. The characteristics of analog and digital both are different, but it gives the actual information from this digital only. So this is nothing but arbitrary waveform generator. Arbitrary waveform generator. Is it clear? Is it clear or any doubt? Please note down. Please note down. Make it fast. See here the points. The basic function generator waveforms are useful for many applications and have been designed into common test procedures. However, it is useful to create more complex, even arbitrary waveforms. This is somewhat typical. So arbitrary waveform generators are in general called direct digital synthesis. See here, this is direct digital synthesis. Synthesis is nothing but getting more using multiple instruments and can be used to generate arbitrary signal variations. The waveform memory contains the digital data representing the waveform we desire. That means this is digital data and which should contains the waveform memory. An address counter sequences through the addresses in the memory, causing the data in the memory to sequential appear at the digital port of the DAC. So this is nothing but related to the address port. The data in the memory to sequential appear at the voltage port, digital port of the DAC. The DAC produces a voltage proportional to the digital data supplied on it. That means that is specified in that particular memory address. Hence, a voltage waveform is produced. The oscillator is used to clock the address counter at a variable rate to change the frequency and period of the waveform. That is, the faster the oscillator clock frequency, the higher the frequency of the output waveform. That means depending upon the clock. So previously here we are taking the clock frequency. Based on that, this clock frequency output will depend. Here its clock frequency is more. Here the cycle frequency is also more, like that. That means the analog output is exactly equals to the digital information. What type of information we are applied to the system. So this is nothing but, see here, the differences between or comparison between conventional function generator and arbitrary function generator or arbitrary waveform generator. See here the first point, please note down. It's a very important one. Standard waveforms only. This is used to generate standard waveforms only. Any wave shape can be obtained here. Design in predominantly analog. Design is digital. Wave shape cannot be stored. Wave shape can be stored. Specifications are analog based. Specifications are digital based. Wave shape adjustment under computer control is generally not possible. That means you are not using any computer based things in generating normal signal generator, normal signals. So, but in this AWG, wave shape adjustment control is possible with variety of techniques. So these are very general ones. Just you got that point of what is arbitrary wave generator. Then these are general things for the comparison of conventional function generator and arbitrary function generator. Please note down these 5 points. It's a very important one examination point of view. Please make that as star mark. Completed. Completed.
No, sir.
It's a very important one, examination point of view. It's a normal view. Just observe the generator. Normal. It's a normal view. See here, 4 waveforms are generated at a time. That is not possible with conventional one. Parallelly, it displays the frequencies also. See here, this is one type of waveform. This is another type of waveform. Those two are connected in a serial. So that is observed here. Sinusoidal wave and it's a pulse. Those two are connected in a row completely. So this is also, it's a ramp signal and it's a normal signal. Here these two are also connected. So this is nothing but our today's class. In this class, we have completed 2 topics. First topic is, what is the name of the first topic?
Random noise generator.
The second one is AWG. In this hour, we have completed these 2. Is it clear, all of you?
Yes, sir.
Okay. Any doubt, please ask me now. In these 2 topics, any doubt, please ask me now. Okay, thank you.